This will be the second video on this specific problem, which is finding the length of the longest substring without repeating character. I am going to write the algorithm and I will explain as I write it. And I will use the input, which is S, to go through to explain the algorithm. And I'll use different input as well. So we have this method, which is, let's say, longest. And this is going to be our input, which is S. First and foremost, let me just discuss what I'm going to do. I'm going to have a space allocated, which is going to be an array of size 128, where this array is technically going to represent all the characters and symbols in memory. So A, B, C, D, which it has its corresponding small a, B, let's say less than, greater than, equals to, all this stuff is going to represent all this. And in the memory there is something called ASCII table, and this ASCII table in memory, if you pass in A, it has a number. If you pass in small a, it has a number. Small a is like 97, B is like 98. So this, we are going to create this space to hold all these numbers, right? So that no matter the string they give to us, we can increase the number as we go, because we've literally found it in this space, right? So that is what we are going to do. So we have this space, then afterwards we start iterating through this input that has been given to us. So we come here, then we start from index 0, which is A. We come there, we increase that. We go to B, we increase that. We go to C, we set that C2, right? Then we find the length, because as we go, as we do it, we find the length as we go. Then we come here, we will see that we've already visited B, because it has already been set, so we wouldn't do anything to it. We see we've already visited the B2, C2 has already been visited, B, then we return the length, which will be 3. Int of, let's say, index new int 128, right? Then we are going to have the integer value of j, which is 0, which will help us to keep track of it. And we are going to have right, that is going to be the return data pretty much. So this is where we iterate. We are going to iterate through the string int I equals to 0, I less than or equals to s dot length minus 1. The length of the string is pretty much 8, but array indexes starts from index 0. So the last value will be 7, right? So to get, we have to stop at the last index. So 8 minus 1 will give us 7, and that is where we are going to start. So we start from 0 and we will be incrementing until we get to the last index. Then we start. So we will first get the value at every specific index we reach. So to get the index there, we have to reference it. And what this is saying is, it says s I here, when we iterate the first time, I is going to be equals to 0. So, and s referencing 0 means we are having the character A, right? So if you do s1, it's going to give us B, and that continues, right? So we have that. Then we are going to set the J, because J is going to help us to keep track of max J, comma, then we come here and reference the index, whether we've set the variable or the character of what? C, because this is the character, right? So the first time it comes in, we've not set their character A. So index A is going to be 0. And J is already 0. So the math.max is going to be 0, right? So we come here, then we also set the return data, which is the length. That one too is going to be math.max return. Here is the key. We are going to start I, then we subtract J, right? Because J is what we are going to use to keep track of whether you've set the index or not, right? Because it's going to help us the number of where we've reached, right? So we first visit A, then we will be going index 0, index 1, 2, 3, right? J will help us to find this A. So we will know, like, we've got to the index 0, 1, 2, 3. Then we subtract I minus J, which wherever that we've reached in I, then we subtract J, what we got here, then we add 1. I'll solve it with the input, and that will actually make sense. That part is a little bit trickish. So we add 1. So then we set the actual value, the actual character, right? Index C equals to I plus 1. Afterwards, then we return the return, which is our data, right? So let's go through, let's first solve this algorithm with the specific input, right? So we come here, we have an input A, like an input of this string, right? The first character is A. We declare this, we come to start iterating through it. I is equals to 0, right? Then we come here, S I equals to A, which is equals to C. J equals to 0. Index at A equals to 0, because we've not set it yet, right? We come here, we do the return. Return is 0 because we initialize it at 0 here. We know I is 0. J is also 0. Plus 1, which is 1. So the return is, what is the max here, which is 1. Return is 1. But after the return, so after the first iteration, so I'll do first return is equals to 1. Perfect. Then the key thing is this. Index C here, C is A. It's equals to I plus 1, which is 0 plus 1, which is 1. So here, we know like the index A is 1. And in memory, the index A is going to be the ASCII character of the word A, which is 97, right? And it's going to be set to 1 for now. So we have a lot of the array, which is 128, start from 0, 1. So this is 0, 0, 2, 0, 3, 0, up to 128. Right? So we have 97, which has been set to 1, pretty much. That's what we are saying. So we've iterated through the first one, then we move on to the second one, which is B. So when we do B, I is equals to 1. S I equals to B. C, which is the same as C, right? J is still 0. Index at B, which is this one, is equals to 0. So J will be equals to the max of 0, 0. And J is equals to 0, right? So we know J is equals to 0. So the return is going to be the max of, we already know return is 1. I, which is 1, minus 0 plus 1, which is equals to 2. Right? So the max of this is 2. So ret is going to be 2 here. That is the second iteration. We will move on to the third iteration. On the third iteration, C, we are on C, and the index is 2. I is equals to 2, right? So we come here, char C, S2 is equals to C, right? So C is equals to C is quite phenomenal, but let's say Si, right? Which is S at 2 is equals to what? C, which is the same as C. I skipped the previous step. I was supposed to say for the B, so this is for the A. So for the B, which is the second iteration, we have to set it. This part should be set. So index at C, which is index at B, which is in memory 98, should be set plus 1, right? And I was 1, so it's going to be 2, right? The second iteration, I was 1. Okay, so we come here and we are going to set the C, right? So we know J is 0 and index at is also 0, so J is equal to 0, so the ret is equals to 2, I is 2, right, minus 0 plus 1, which is equals to 2 and 3, so ret is equals to the max, which is 3. So after the third iteration, we know that C is, the ret is 3. Perfect. Then we set that index. So C, remember, is going to be 99, which is going to be 3. Pretty much. So we keep going. So the next iteration, I is equals to 3, and we know S I equals to A, right? So what we are going to do now is we are going to find J, right? And we know J is 0. Index at A, already know we set it to 1. Pretty much. So we come to the red. We know red is 3. I is 3 minus 1 plus 1, right? This will cancel each out. Then it will be 3, 3. So red keeps at 3. This A wouldn't have any effect. So red is 3. Then we have to set A again, right? So index at A, we know I is 3. 3 plus 1, which is equals to 4. So 97 is going to be 4. Now, perfect. We are on, move on to the next iteration, 0, 1, 2, 3, 4, which is I equals to 4 and S at I is equals to B. We are on this one, right? We find the math.max. The last time we were able to get J, a value, I already erased it, but I think it was J 0 index of A, which was 1, right? So J was 1. I have to keep track of it, which was 1. And index at B is 2, because we have it there. So after this iteration, J was 1. Okay. So it's going to be 2 here. So J equals to 2. So let's keep track of J now, because J is being set now. J is 2. Red, we know red is 3, right? I is 4. 4 minus 2 plus 1. And we are going to get 3, 3. And red keeps being 3 after that iteration. Important thing, we have to set B again. Index at C, which is B. C is B, right? I is 4 plus 1, which is 5. So this is going to be 5 now. Perfect. Then we move on to the next one, which is C. So I at 5 is C. S at I, which is C. And the value C. Index at C gives us 3, right? We know that J is already 2, so the max of 2. Index at C is 3. So we then get J at 3. And this J is equals to be 3, right? Then we try and find the red. Red is already at 3. I, which is 5, minus J, which is 3, plus 1, then we get 3, 3, and the red remains at 3, right? Whilst J is 3. More important to know, index at C is going to change. I is 5, then plus 1, which is 6, right? So then we go on to I at this index, which is index 6, right? At index 6, what we are going to get is S at I is equals to B, which is C, which is this character. So J is equals to the max of, we know J is 3 now, index of C now, which is index of B, is 5. So then J equals to 5. Keep track of it. Come here. Red is 3. I, which is 6, minus 5 plus 1. And we have 3, 2, 1, 2. Red still keeps being 3. We don't change it, but we have to set the value as C, which is indexed at B. So we have to change B. I is 6 plus 1, which is 7. So we come here, we change it. Okay. We move on to I at index 7, which is this last index, which is goes to 7, right? S at I is equals to B. Then, which is the same as C, right? Then we find J. We know J is the max of 5 and index at C, which is index at B. In this case, it's 7. So J equals to 7. Then we find the red, which we know red is at 3. And we know that I is 7 minus J, which is 7 plus 1. And we are going to get 3, the max of 3 and 1. We know red still keeps at 3. Then index at C, which is in this case B, going to be 7 plus 1. Then we get 8. So then we keep track of this too, which is 8. Then we come here, we increment I, which I equals is going to be 8. 8, this will be false. Then we will be out of the for loop. Then we return, which the return type is 3. And that will be the length of the substring without repeating character. So this is the process of stepping through and understanding the algorithm. And this algorithm is pretty much going to work for even no matter the size of the input that is going to be given to us. The algorithm is going to work. Just to give you a trial, you can follow the same explanation and try it with an input of P, W, W, K, E, W. So just try and use this input to go through the algorithm and try and do it on your own. If you got any question, please comment below in the comment section, or feel free to email me directly. I will be glad to reply you. I will be posting another video on implementing the algorithm and stepping through the algorithm on Visual Studio Code, and I will explain it there too. There we could clearly see there what the array index hold and what the value at A holds and B holds and C holds at each iteration. This will help you to comprehend it. I believe stepping through algorithms step by step like this will help you as a learner to comprehend it, and this will help you in future if you try to develop your own algorithm for it to be easy for you. Now let's talk about the important part of this, which is the time complexity and the space complexity. Because we stepped through we visited each of these characters, so on this loop, our big O of n is going to be n, right? And the space complexity is going to be O of 1. We have a constant space complexity and we have a linear big O notation, right? And that is what we have. So this is going to be going to be run on a linear time, and the space is going to be constant because we pretty much have a fixed size of array declared. I'll be posting more of interview questions and solutions on this same playlist, which is data structures and algorithm. I believe you did enjoy the video. If you did, please subscribe, and also don't forget to hit the like button. You can also leave a comment in the comment section or send me a direct email. I'll be glad to reply. Till we meet again, I will say bye-bye.